Welcome to the session number 9 from the playlist of properties of matter. The topic is the thermal stresses and strain. So with regards to this topic, I have written here 3 important points. And the first point is that when a body is allowed to expand or contract due to the increase or the decrease in the temperature, then no stresses are induced. That is, stresses are not induced if the body is allowed to expand or contract. This is a very important point. The second important point is that when the stresses are only induced when the deformation of the body is prevented by some external means. So when the deformation of the body is prevented by some external means, then the stresses are induced in the body, and those stresses are called the thermal stresses. And the corresponding strain which is developed in the body is called the thermal strain. So this was the second important point, and the important thing is that stresses are induced only when the deformation of the body is prevented. Now third point is that if alpha is the coefficient of linear expansion of a body, then as we have already studied that in the chapter of heat and thermodynamics, that the change in the length will be equal to the original length multiplied by the coefficient of linear expansion multiplied by the change in the temperature. So delta L will be equal to L into alpha into delta T. So from here, thermal strain. The thermal strain is what? That is equal to delta L upon L. That is the change in the length divided by the original length. So delta L upon L, which is the thermal strain, this will be equal to alpha into delta T. So this is what I have written here. So the corresponding thermal stress, now we know that Young's modulus Y is equal to, it is equal to stress upon strain. So the thermal stress will be equal to Young's modulus multiplied by the thermal strain, which is equal to alpha into delta T. So the thermal stress will be equal to Y into alpha into delta T, where Y is the Young's modulus of that body. So thermal strain is equal to alpha into delta T, and thermal stress which is induced in the body due to the change in the temperature will be equal to Y into alpha into delta T, where Y is the Young's modulus. And the corresponding tensile and the compressive force. Now, if we know that stress is equal to force upon area, so the corresponding tensile or the compressive force will be equal to the thermal stress multiplied by the area of cross section. So the thermal stress is equal to Y alpha delta T multiplied by the area of cross section. So the corresponding tensile or the compressive force which will be produced in the body will be equal to Y alpha delta T into A. So this was a small note on the topic of the thermal stresses and strain. In the next session, that is in the session number 10, I will be coming up with a very simple question which will be based on this topic, that is thermal stresses and strain. So till then, have a nice day. Bye.